Hi students, this is continuation class of permutations and combinations. In previous sessions, you learned number of odd-digit numbers formed by using n digits without repetition. If 0 is not included and 0 is included. Now, in this session, I am going to teach you number of odd-digit numbers formed by using n digits when repetition is allowed. That is, today contents odd-digit numbers formed by using n digits with repetition. 0 is included and 0 is not included. And definition of palindrome. So, number of palindromes of odd-digit numbers formed by using n digits. 0 is included and 0 is not included. Now, see the theorem. Let n and r be positive integers. If the repetition of things is allowed, then number of permutations of n dissimilar things taken r at a time is n to the power r. Proof of this? The required number of permutations is equal to number of ways of filling r blanks by using n things. When repetition of things is allowed, the first place can be filled by any one of n different things in n ways. So take r places. First place filled by given n dissimilar things in n ways. When repetition is allowed, that means again we have n things. So second place also filled by n ways. Similarly, all the r places can be filled by n ways. Since repetition of things allowed, the second place can also be filled by any one of n different things in n ways. Similarly, every blank can be filled in n ways. By continuing principle, the r blank places can be filled in n to the power r ways. Then required number of permutations equal to n to the power r. See example. Find the number of 4-digit numbers that can be formed using the digits 1, 2, 4, 5, 7, 8 when repetition is allowed. Solution. The number of 4-digit numbers that can be formed using the digits 1, 2, 4, 5, 7, 8 when repetition is allowed. That means here r equal to 4 and given digits n equal to 5. So by using repetition n to the power r, then it is 6 to the power 4, that is 1296. See the formula. Number of odd-digit numbers formed by using n digits with at least one repetition, that is odd-digit numbers formed by using n digits with repetition minus odd-digit numbers formed by using n digits without repetition, that equal to n to the power r minus npr. See corollary on this. The number of permutations of n dissimilar things taken not more than r at a time when each thing may occur any number of times. That means this is also when repetition of things is allowed is n into n to the power r minus 1 by n minus 1. Note, when repetition of things allowed any number of times in the formation of permutation of n things taken or at a time, the number or need not be less than or equal to the number n. Definition of palindrome. A number or a word which reads same either from left to right or right to left is called palindrome. Example, Amma, Rota, and 1, 2, 3, 2, 1 like this. If you see this, if you observe this, if reads either from left to right and right to left, both are same. Note, the number of palindromes with r distinct letters that can be using given n distinct letters is, first one is n to the power r by 2 if r is even, and second one is n to the power r plus 1 by 2 if r is odd. Example, find number of, first one is 6 letter palindromes that can be formed using the letters of the word equation. Here r equal to 6 and the equation word contains 8 letters, so n equal to 8. Then here r is even, then number of palindromes is n to the power r by 2, that is 8 to the power 6 by 2 is 3, so it is 8 cube. And number 2, 7 letter palindromes that can be formed using the letters of the word equation. Here r equal to 7, n equal to 8. r equal to 7 which is odd, then number of palindromes equal to n to the power r plus 1 by 2, then it is 8 to the power 4. See example, find number of 7-digit palindromes that can be formed using the digits 0, 1, 2, 3, 4. So among the given digits here there is 0. Then first place can be filled in 4 ways. Here r equal to 7 and n is equal to 5. Among the given digits there is 0. That's why r is 7 means take r plus 1 by 2 places. That is, take 4 places. First place cannot be 0. Then this can be filled by 4 ways by using non-zero digits. The remaining 3 places can be filled by given 5 digits in 5 cube ways. Therefore, number of palindromes equal to 4 into 5 cube. Now, definition of derangement. If there are n things in a row, a permutation of these n things such that none of them occupies its original position is called a derangement of n things. Note, the number of derangements of n distinct things is n factorial into 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial and so on plus minus 1 to the power n into 1 by n factorial. Example, find the number of ways in which 4 letters can be put in 4 addressed envelopes so that no letter goes to in the envelope meant for it. That means all letters goes to wrong place. Solution, required number of ways. That is, here applying the formula n factorial into 1 by 2 factorial minus 1 by 3 factorial plus and so on minus 1 to the power n by n factorial. For this problem, n is 4. So it is 4 factorial into 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. Then 4 factorial factorial is 24 into 1 by 2 minus 1 by 6 plus 1 by 24. Then we get 12 minus 4 plus 1, that is 9. See one more formula. Number of ways in which n letters can be put in addressed envelopes. All letters go to wrong place. That is n factorial into 1 by 2 factorial minus 1 by 3 factorial plus and so on plus minus 1 to the power n by n factorial. And second one is exactly all letters go to wrong place. That is NPR into 1 by 2 factorial minus 1 by 3 factorial plus and so on plus minus 1 to the power r into 1 by r factorial. See the problem on this. Number of ways in which 5 letters can be put in the envelopes. 3 letters go to wrong place. That is, here n is 5 and r is 3. Then we apply npr into 1 by 2 factorial minus 1 by 3 factorial plus and so on plus minus 1 to the power r by r factorial. Then we get 5p3 into 1 by 2 factorial minus 1 by 3 factorial. So this is 60 into 1 by 2 minus 1 by 6. We calculate, that is 20. Thank you.